In the name of God, hello dear students, welcome back to Perhua's website. My name is Masoud, I'm a physics teacher. In previous lessons, we explained we proved two more laws of motion with constant acceleration. Right now, we are going to solve a sample problem regarding these laws. Sample problem 1D, page 90. Let me read the question for you. A plane is starting at rest, right? Starting at rest. I suggest you to summarize any information, let's say within the question, whenever you reach a number, whenever the problem mentions any value, uh, I want you to summarize it for yourself like this. It says a plane is starting at rest. You have to write initial velocity is equal to zero. At one end of a runway undergoes a uniform acceleration of 4.8 meters per second squared. So this is acceleration, right? For 15 seconds, this is time interval. Before takeoff, right? Before takeoff, what's its speed? What's its speed at takeoff? So we look for final velocity. This is the first unknown. We have two unknown. How long? How long means we look for x. How long must the runway be? Because it talks about the runway, and runway is a path uh, that is the path over which the plane is traveled. Right. That's why delta x and v final are unknown. This is the summary. Initial velocity zero, acceleration is this number, delta t. The units are unified. It doesn't need any conversion. Actually, it takes two steps, right? The first step, v final is equal to v initial plus a delta t. This is the rule that we proved it in the previous lesson. Vf is equal to 0 plus 4.8 times 15, and the answer is 72 meters per second. Right? Just substitute the values to find the final velocity. But to find the displacement that is traveled, uh, actually that is covered by the plane, uh, we have two options. Either you use this law or another law, as you wish. You are free to use this one or this one. It's optional, arbitrary, right? Maybe you say, teacher, I'm gonna use this rule because it doesn't have uh, any exponent. This one is easier, and maybe uh, you forget this rule. Maybe you forget this rule, but this law comes to your mind. Excuse me. This law comes to your mind, and you obey this law. That's why you are free. It's optional, but I mentioned both both laws, and keep in mind that you have to get the same result. Let's say whatever rule is used, actually it doesn't matter. You have to get the same result. Delta x is 540 meters. Whenever you get it here, if you use another rule, right, to make sure your answer is true, you have to get the same result, right? For example, one student chooses here and the other chooses the other rule. Delta x is equal to 1/2 v initial plus v final, the whole bracket times delta t. This is I think, the first law that I proved it for you. Delta x is equal to 1/2 0 plus 72. This number 72, we've already solved it in first step because we haven't had it within the question. Multiply by 15, so 72 plus 0 becomes 72 times 15. I want you to multiply these numbers together, and after that, I want you to divide it by 2 to get this number, 540 meters. Right. Maybe another student, your friend, uses this line. It's okay, no problem. Delta x is equal to VI delta t plus 1 over 2, or plus 1 half A delta t squared. Delta x is equal to 0, multiplied by 15 plus 1 half acceleration 4.8. We've already summarized it here, actually, right? Times 15 squared, and the answer is the same, 540 meters. That's all, guys, for today. Thank you very much for watching this video, and bye.